Hello guys, welcome back to my channel. Today is the second video about the Revopoint POP 4. So if you did not watch the first video, I really think you should, because it covered a tiny bit of everything related to the scanner. So the POP 4 is able to scan a bit of everything. So it has several scanning modes, like it can use infrared, it can use single line, cross line, different tracking mode. So you can use markers, you can use features, you can use global markers, you can use color tracker, so it's very nice. Everything is explained in the first video. So it would be nice if you are interested about that scanner to have a quick look. So now we will try to focus a tiny bit more about one special feature that scanner is offering, which is Gaussian splatting. So Gaussian splatting is pretty cool. So let's talk a tiny bit about how things work in a way. So if you work in the VFX industry, you're making, movies, or if you're doing video games, there are several ways of putting your models into the engine or into the VFX software that you want to use. So, or you can build everything yourself, which is an option, or you can use a scan. So when you scan stuff, you have several types of scanning method. First one could be a desktop scanner with a laser desktop scanner. I used this kind of scanner like 20 years ago. It was pretty cool, but it was incredibly long to scan. Then I moved to a bit of infrared scanning and photogrammetry. So for example, I have a POP 1, I have a range, I have a Miracle Plus, which are all infrared scanner. So then there is another technology which is a laser scanner. So I have a Metro Y Pro which is doing laser scanner, for example. And then I have the POP 4. So the POP 4 is able to do the two of them. So it's able to scan using infrared, and it's possible to scan using a laser using the POP 4, which is very, very convenient in a way. So that's pretty cool. But there is another way of making 3D scanning, which is photogrammetry. So for example, to make it simple, you have two eyes, okay? And if you cover one, you just see stuff in 2D. And if you have your two eyes, you see stuff in 3D. Photogrammetry works a bit like that. You take, sometime 100, 200 pictures, and it's like tiny eyes, and it helps the software to generate a 3D model. You can do it from a camera, so it's pretty easy. There is a few bad points with photogrammetry. First, it's a bit noisy. Secondly, there are some aspects where it does not work well at all. Like for example, the trees, when you see all the leaves and everything, photogrammetry is not good for that. So technology evolved a bit into something which was previously called NERF. And then it moved into Gaussian splatting. So Gaussian splatting works a tiny bit like photogrammetry. So it works mainly from pictures. So the main difference is that photogrammetry will use geometry, triangulated geometry, and Gaussian splatting is something different. So it uses a kind of a cloud point. It's the same format anyway, so it's PLY. So PLY is the format used for cloud point, and it's a format used for Gaussian splatting. So it could be PLY or splat. Instead of creating a normal 3D model made of polygons like traditional photogrammetry, Gaussian splatting represents a scene using millions of tiny little dots called Gaussians or splat. Think of them like soft, blurry particles floating in space. Each one has a position, a size, a rotation, an opacity, and a color that can change depending on the angle you're looking at it from. Now, what's interesting with the Revopoint POP 4 is that it doesn't do a classic Gaussian splatting. It first creates real geometric scan, and then it uses that geometry to help align all the images. This hybrid approach gives cleaner result with fewer floating artifacts compared to regular Gaussian splatting. Okay guys, so here we're back into RevoScan. So as you can see, this is the raw data. So you can have a look at the model. This is a raw point cloud, low resolution. It's just something about a display. So then, like I showed you in the previous video, you need to make a fusion. So here is the fusion was made at 0.2, and that's the result of the fusion mesh. So as you can see, it's already pretty cool. The quality is pretty nice, but this is just a fusion of the point cloud. So instead of having, I don't know, for example, if you look on the raw data, there is 5,677 frames. So it's technically 5,677 point cloud, which are together, you know, grouped together, but you want one. So you need to fuse everything. So that's what the fusion is doing. So when you fuse a model, then you go into isolation, overlap, you go through a process which I covered in the previous video to remove, you know, all the unwanted pieces which could be on your model. Then this is still one point cloud. So you need to create a mesh, a geometry. So I will just click on it. Okay, so that's the geometry. Okay. So here you can see the geometry. Okay. And the geometry has textures. So as you can see, it has textures. So now we are focusing everything on Gaussian splatting for these videos. So as you can see on the top, you have, for the texture, you just click color image or vertex coloring. So usually I go color image and I just apply. And then after that, you have 3D GS, which is 3D Gaussian splatting. So you just can go high quality, medium quality, lower quality. So just keep in mind that creating a Gaussian splatting, you know, for the textures and everything would be a bit more time consuming than just the classic textures. I just mean, it won't be more complex. It would just be a tiny bit longer. So the computer will have to process a tiny bit longer. I made several tests, everything in high quality, and I will just click on it, go for it. Okay, and that's the Gaussian splatting. When you look carefully at the model, you can see that the lighting is moving on the geometry. So as you can see that the light is changing depending of the position of the model with the camera. So when the movement is changing, the light is changing on the geometry. So like I explained you about Gaussian splatting, there is different size for the splat, different opacity, different color, lighting, different angles. So the same splat could have various information depending of the position of the camera. So if I go back on mesh, I click on mesh, if I move the model, the lighting is not moving at all. It's completely baked and there is just a flat lighting in a way. But if I click on the splat, it's different. So it's like everything is still preserved. So if I have a very strong light on the front, when you will turn the model around, you will still preserve the lighting information. So it's pretty interesting. So this is what the model looks like into RevoScan. So it's pretty cool. I made a few scans. So I made this one, and I have the one from the Venatosaurus from King Kong that we scanned on the previous session, on the previous video. So now I will just explain you how to put this into Unreal Engine. So I will just close this. Okay, so something to keep in mind. If you just make your splat in PLY format and you drag and drop into Unreal Engine, it won't be supported. So it's not working, you know, instantly like that. So what I did is that you have tons of free plugin where you can just, you know, download the plugin for free. You put it into Unreal Engine, and then it would just make things work. So I personally used that one, Nano Gaussian Splatting from Team Chen 1383, and you just have to click here on the code and download zip. So we'll download the zip file that you will have to unzip, and then you will just create a project into Unreal Engine. And what you have to do, where it is, just one sec. Okay, and what you have to do, for example, is that my project name is named Test 3DGS, and I just created a small folder named Plugin, which is here, and then into it I just drag and dropped Nano Gaussian Splatting, and this would make possible the import of the Gaussian Splatting. So it's very easy. You go on the website I gave you, you download the zip, you unzip the file, and you drag and drop the file into the plugin folder. And then you would just have to drag and drop the model into Unreal Engine. Okay, so here it is. Now we are in Unreal Engine. So you can see it's, look at that. Look how quick it is. It's not slowing down anything. So that's something which is pretty cool and nice. So what you have to do, I just go in the content, drawer, and then you have the plugin. In the plugin, you have something called Nano GS, and you just drag and drop the PLY file into this folder. And then you take it and you drag and drop it into the scene. One small thing is that Gaussian splatting are coming in very various scales. So for example, if you drag and drop a figure and it's supposed to be a human, it's supposed to be 1.8 meters tall, you could drop the Gaussian splatting into it, and in the engine it could be 100 meters tall. So you will have to adjust the size. As you can see, the quality of the Gaussian splatting into Unreal Engine for now looks a tiny bit less good than what Revo 6 is doing. I'm not sure why. I'm not incredibly familiar with Gaussian splatting into Unreal Engine, and I need to dig more. Because if Revo 6 is able to deliver, that quality here, Unreal Engine should be able to deliver the exact same quality. So maybe the plugin I downloaded is not the best. I don't know. Maybe there are some parameters to put into Unreal Engine that I do not know. Maybe. But anyway, you should be able to get that quality into Unreal Engine. And if it's not the case on my particular scene, it's probably because there is a few tiny options to tweak, just so you know. I would encourage you to make some splat, put them into Unreal Engine, and if you have any more information, if there is some parameters to tick, if there is any option in the rendering to tick, just let me know. I would be highly interested to know more. So do not hesitate to comment and to tell me, oh, okay, maybe the quality is not good enough, you should have tweaked that parameters, or you should have done this and that. Just let me know if you have some more information, and it would be very useful for me. I'm trying to give you information, and if you could give me information on your side, if you have them, it would be very nice. So I hope you really enjoyed that video. I hope they are very useful to you. And I'm pretty happy if it could help some of you to have a better understanding of how Gaussian splatting works, how it works, especially for the POP 4. As you can see, it's very easy to do. You just have to make a classic scan. You turn, color on, you process the color, and then you process the Gaussian splatting. And it would work pretty easily. Then you export in PLY. You add a small plugin to Unreal Engine, and then boom, drag and drop. So for now, there is probably a few other options, to activate into Unreal Engine. I don't know. I'm not incredibly familiar with Unreal Engine, to tell you the truth. I'm more into movies than a game. But I will change this anyway. I need to adapt and learn a tiny bit more of Unreal Engine. And knowing that I can generate, Gaussian splatting with that scanner is something very nice. No floating pieces, which is the biggest advantage, of the scanner. So of course, if you make a scan with the $5,000 camera, the lens and the quality and the sharpness would be better than the scanner, just because the camera costs 10 times more. Of course, if you have two machines and one of them costs 10 times more, it should do a better job, of course, for the sharpness and everything. But what you have to understand is that that's something which is not the first purposes of this scanner. This scanner, something which is very nice, is that the versatility, it means it can do a lot of different things. So scanning infrared, scanning with laser mode, tracking using textures, tracking using trackers, or using feature mode, doing a bit of Gaussian splatting. It's packed with AI technology, lots of advantages. And the scanner does not cost a lot. That's something which is very nice. If that's, for example, your first scanner, I think it's really affordable for you to get something like that. And it can do a tiny bit of everything. So this one could help you to familiarize with 3D scanning, make a bit of everything. And then at some point you could just think, okay, maybe I will get a second scanner. Personally, I have 6 of them. So I'm the kind of people who have lots of scanners. Some of them have different utility, but this one is able to do everything. So that's the end for the second video. I really hope it was useful. I really hope it gave you more information about Gaussian splatting. I hope everyone understood what I was saying, and understood the process and everything, including how to put stuff into Unreal Engine. So do not forget to like and subscribe, just to show me you like, the content. And see you soon on the next video. Bye-bye.